Hello. In this video, I'm going to be explaining problem 2 from the 2016 F equals MA contest. In this problem, we have a cylinder immersed in both oil and water, and after such that 1/3 of the cylinder is in the oil, 1/3 is in the water, and 1/3 is above, just in the air. Afterward, more oil is poured so that the cylinder is then floating just in the oil, and the problem asks us to find what fraction of the cylinder is in the oil. So the first thing to do in this problem, so you see that the density of oil and water are both given as numbers, but really the best way to do this is that we want to abstract away from these numbers, that you don't have to deal with the specifics of 800 and 1,000. And so what we should do is just to start, we can just write rho oil as 4/5 rho of water, or alternatively as rho water being 5/4 rho of oil. Now, you might ask, which one of these should we use? It doesn't really matter, but I'm actually going to use this one. And the reason is that if you look at this diagram right here, the after situation where we need to find what fraction of the cylinder is in the oil, ultimately, let's say that the density of the cylinder is just rho, so that's the density of the cylinder, then ultimately the fraction of the cylinder that is in the oil is just going to be rho of the cylinder divided by rho oil. And so if we express everything in terms of rho oil and then just find rho in terms of rho oil, then that will just give us our answer. The fact that I've just cited here is basically a well-known fact, but it's a direct consequence of Archimedes' principle, which of course we will use to handle the first situation. So to handle our first situation and to calculate rho in terms of rho oil, so we have something like this. We need to calculate the total buoyant force on the object. So here we have a volume of V/3, so I'm going to say V is the total volume of the cylinder. And so we have V/3 in the air, V/3 in the oil, and V/3 in the water. And so the total force, so the gravitational force, is equal to the mass of the cylinder times the gravitational acceleration, and the mass is just rho times the volume. So we get rho Vg. Now, what is the buoyant force? Well, it equals, by Archimedes' principle, you're going to get, it's equal to the weight of the displaced fluid. So what is the weight of the displaced fluid? Well, first we have a certain amount of oil that is displaced, so that's V/3. That is the volume of the displaced oil. And then to get the weight, first you have to get the mass, so multiply it by rho oil. Oh, sorry, well, we just call it rho O, rho sub O. So rho of the oil, and then so that's the mass. And now to get the weight, you multiply it by gravitational acceleration. And then you'll get another term like that, rho sub water, because there's once again V/3 of the water. And then to get the mass of the water, multiply by the density of the water, and then to get the weight, multiply by the gravitational acceleration. And now these two are just equal. So setting Fg equal to Fb, we get rho Vg equals V/3 rho oil times G plus V/3 times rho water times G. And very nicely, V and G just cancel out of everything. And so we get rho is just 1/3 rho oil plus rho water. And rho water is 5/4 of rho oil. And so rho will just be 1/3 times 9/4 rho oil. That will be, that will be 3/4 rho of the oil. And now, when we're in the situation where we have just the oil, So I'm not going to draw the water. I'm just because I mean it's far enough down that the block will not be submerged in it. We're going to get a situation like this. And so now the question is what fraction, so let's say fraction submerged in the oil, will be S. And so now we want to find this, what fraction will be submerged in the oil once you pour in enough oil. And so now the gravitational force, that's still rho Vg, but now the buoyant force is just the amount of oil that is displaced. So that's the volume will be the fraction times the total volume, so SV, then multiplied by rho of oil times G. And so now setting these two equal, rho Vg is SV times rho oil times G. Again, V and G cancel out. And so we see that F is indeed rho over rho zero, as I meant, or rho of oil, rho of oil, as I mentioned earlier. And as we discussed, that's already calculated that to be 3/4. So that's the fact that I mentioned, that if you have a solid immersed in a single fluid that's floating, then the fraction that is submerged, the fraction of the volume that's submerged is equal to the ratio of the two densities. That is something that you can calculate directly from Archimedes' principle, as I showed here, but it's also something that's worth just committing to heart. And so now, to finish the problem, let's go back to our options, and we see indeed that 3/4 of the cylinder is in the oil, and so our answer is option B. All right, so that finishes this problem, and I hope that was helpful. Thank you for watching.